Woohoo! We are live! Yay! This is Math 60 Intermediate Algebra, and we are in Chapter 2, and we're going to be graphing! Yay! And in order to graph, you really need to either have a printout of the notes, which will have this grid, or go get yourself some graph paper, otherwise known as quad rule. Quad for 4. I don't know if it means, I guess it means it's drawn in little squares. So quad rule pads or paper, because graphing freehand is going to quickly get you some really wonky looking graphs. So definitely get a hold of something that has semi-regular squares on it so you can practice that. You will also need a ruler, because for the most part, we're going to start off with lines, and lines are easier to do with a ruler. And then I personally, again, handy dandy highlighters. Get yourself some highlighters that you like, and of course, a pen or pencil. So we're going to be doing graphs. Now, to be honest, this should, in intermediate algebra, this should all be reviewed. The entire 2 pages that we're going to talk about, I'm going to go through some vocabulary, things like x-axis, y-axis, quadrants, etc. And this should all be something you're familiar with. So we're just doing it to brush up. Now, there's one other topic in 2.1 called midpoint. You may never have heard that before. So there is one new thing. But this, the 2 pages, should not be brand new. So I'm not going to go very carefully through it. It's just going to be a review. So I go pretty quickly. So if you have any questions, talk to me, talk to a tutor, talk to your friends, you know, go out on the street, ask random people, see if they can help, etc., etc. Okay, so graphing, woohoo! So identify the following on this graph. X-axis and y-axis. I'm going to start off not doing it here, but doing it over here. Sorry, I'm having some allergies, so I have some sniffles. Generally speaking, we've got 2 axes, and the word axis basically means line. And so axis being the line means x-axis is the x line. Here's the x line. Y-axis is the y line. That's this one. The x-axis is the horizontal axis. And the y-axis is the vertical axis. And so we use those 2 to give us a way of counting up and down on our graph and our way of counting left and right. Now, very quickly in math, once you get the basics of graphing, we don't leave it as x and y. These 2 axes, and notice axis is the singular, but axes, we usually exaggerate it as math teachers so that you guys can hear us. It's the plural. And very quickly, we're going to switch off of x and y. We could go to t and q, or this could actually, if you continue with math, this could be the y-axis, this could be the x-axis. So lots of shenanigans, but for right now, x and y are where you think they should be. We've got the quadrants. The quadrants are this idea that in our, I'm going to draw it again over here where I've got a little bit more space with my y-axis. Oh my goodness. There's a ruler right here and I'm just ignoring it. Oh, dangerous. Don't try this at home. Use a ruler. Remember, I'm a professional. I know what I'm doing. Okay, so we got the x-axis, the y-axis, and then we're going to break. We imagine these lines are infinite. We can't draw them in their infiniteness, but they keep going forever. And so they chop up the plane, not the airplane, but the plane that we're writing on, this piece of paper, into 4 pieces. And we start counting here. And then weirdly enough, take my word for it, I know this is weird, but if you continue with math, and you'll get to a point where you're like, oh, I see why they did that. Second quadrant, there's the first quadrant, second quadrant, third quadrant, fourth quadrant. Now, some people do use quote unquote normal or Arabic numbers. I'm using Roman numerals because that's tradition. And these are the quadrants. Quad for four. There are four different sections. And this is going to be useful because if I ever ask, what quadrant are we in for this point? You could be like, oh, we're over here. We're in the third quadrant. Or I think it'll be in the first quadrant. It's just a way of orienting ourselves on the graph. Number 3, rectangular coordinates or Cartesian coordinates and an ordered pair. So rectangular coordinates refer to the fact that this grid is drawn with squares. And in fact, as I move along, I'm going to move left and right, horizontally, or up and down, vertically. And that's going to create little rectangles. And you might have asked, do we ever use other types of shapes? And the answer is absolutely. And let me pull out a piece of paper. Sometimes, and again, not very long from where you are now, if you continue on with math, sometimes, and again, I'm throwing caution to the wind. Let's pretend. There we go. Oh, look at that. Beautiful. Instead of drawing rectangles and squares, we draw circles. And we use something called polar coordinates. So when someone asks you, well, is there anything other than rectangular? Absolutely, circles. It's called polar because this is the pole, you know, some other reasons. It's very exciting. I can't wait for you to get there. But right now, let's stay here. Cartesian coordinates. Cartesian coordinates are named after Rene Descartes, who was very famous for saying, I think, therefore I am. And he was a philosopher, mathematician, and he is remembered as the one that came up with this. Now, I know I'm making a video, so you guys can go fact check me, but I'm gonna remind you that in math and science and pretty much anything, a lot of times there are a lot of people working on something, and the person who gets famous is either the person who just happened to be able to publish it first, or the person with the most money, or the person with the most fame. So I can't guarantee you he was the guy, but we did name it after him. So go look, go fly and run off and Wikipedia the heck out of Rene, and you know, come back and let me know. Next thing, an ordered pair. So an ordered pair is a beautiful description of the fact that mathematicians tend to describe things in a very utilitarian way. Ordered means one comes first, one comes second. Pair means there are two of them. And again, it's that idea that I'm going to have an X value, that'll tell us how far we go left or right, and a Y value, which tells us how far we go up and down. So X and Y are the ordered pair. Again, the ordered means X comes first, Y comes second. Pair means there are two of them. So the next thing is, you're going to ask me, are there ordered triples? Absolutely, X, Y, Z. That would allow us to take this flat graph and move it out into, ooh, 3D. Look at that. Ooh, it's almost as if you're right here. Okay. Next up, scale. Scale always makes me think of dragons or fish. But scale in this case tells me that if you just pick a point and I say, okay, there's our point. Do you know what the coordinates are, or what's the ordered pair that represents, or that this point represents? And the answer is, well, I have no idea, because this X value could be 1, or it could be 1,000,000, or it could be 14. Who knows? You have to write scales on your X axis and your Y axis. Pardon me. Sorry about that. Oh, these allergies. Next up, the origin. Now we're going to start graphing. So I'm going to have to take my grid, and it's traditional, so I'm going to go ahead and do the traditional route. It's traditional to put your axes just in the middle. I don't care if they're exactly in the middle. Just pick a likely suspect and go ahead and draw in. I'm using this highlighter because I think it'll be easier to see than the black. Now, this is a matter of style, but I believe that all the axes should have arrows. Some people only put arrows on some of them. I get freakishly attached to my arrows. So for my class, arrows everywhere. There's an X, there's a Y. It's kind of like they're little protective little things so that no one gets poked by the line. If you like to think of it that way, go for it. Okay, first thing, the origin. Origin means the beginning. And where we start is right here, in the middle. 0, 0 means I've gone nowhere for X and nowhere for Y. Woohoo. Okay, I'm going to regret writing that there because I think there's some other points I need to put right there, but good. Now, 6 through 9, you'll notice, are all the different variations I could come up with on negatives and positives. So I'm interested in the point -2, 3, -2, -3, +2, 3, and +2, -3. Now, right now, if I were you, I'd be looking at that going, wait, how do I know those aren't ranges of numbers? And the answer is, that's a good question. And another answer would be, you know, by context. These are coordinates because we're talking about graphing. Okay, so shall I start graphing? Now, in order to graph, again, I need a scale. I could go ahead and just make each one of these. This is 1. This is 2. Make this 1, make this 2. And there's nothing to stop me from doing this. I could also choose to count out 2 spaces and make that 1. The scale is up to you, and it's going to depend on what you need to do. These points are all relatively close to the origin, so I don't need a lot of space. If one of these were 17, I want to make sure I oriented this so I don't run right off the page. So it's something that we're going to play with as we go through. Let me see. I've already used purple, so number 6 is going to be my yellow point. Let's see, I'll do yellow, and then pink, and then blue, and then orange. Just in case anyone needs to follow me. So let's start with yellow, -2, 3. So that means X equals -2, Y equals 3 at the same time. So X equals -2. I haven't done the negatives yet. So remember, if I'm counting 1, 2, 3 to the right, I'm counting -1, -2, -3 to the left. Same thing as I count up 1, 2, 3 on the y-axis, I count down will be the negative. Okay, so -2, 3, I move from the origin, -2. So I move 2 to the left and then up 3. 1, 2, 3. There we go. Oh, I'm sorry, I took you to Smerry Town there. So a couple things I can do. I can denote the scale on the axes. I can also just come in here and just write in explicitly that those are the coordinates. Over here, I'm going to point out that this means left 2, up 3. And there we go. Even though it's Smerry Town, there's our point. Let's look at this one. -2, -3. So X is -2, Y equals -3 at the same time. And that's going to be left 2, and then what? It's -3 for Y. That means you got it, down 3. Woohoo! And that one's pink. Okay, so I'm going to go left from the origin, 1, 2, and then down, 1, 2, 3. right there. Let me see if I can avoid Smeary Town. More or less. Okay, and this is -2, -3. Woohoo. Okay, blue's up. Next one, 2, 3, or 2, 3. X is 2. Y is 3. Means I'm going to go +2. So I'm going to go to the right 2, and I'm going to go up 3 from the origin. Okay, 1, 2, 1, 2, 3. And that guy is blue. Woohoo. And then 2, -3. X equals 2. Y equals -3. So that's right. 2 and what? Yep, down 3. So we're going to go 1, 2, 1, 2, 3. Ah, dodged it right there. Woohoo. And that's orange. L'orange. Okay. So those are our four points. We could identify each of these. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So I could say, for example, if I said number 8, the blue one, what quadrant are we in? And you would look, you go, oh, first quadrant. Woohoo. So that's how we use the quadrants to kind of get an idea of where things are. And the last thing is open points versus closed points. And what I will just do, sorry, this shifted a little bit. Oh, mirrors are so fun. Okay, this is ridiculous. I'm never going to be able to finish this. So let me remind you, I think I've done this for you before, a closed point, the pen stays in. An open point, the pen falls out. So an open point does not include the point. Oops. And a closed point looks like this. So make sure when you're drawing your points, you fill them in completely if you mean that it's closed. It does include the point. And we use, this one does not, this one does. We will use this more as we move on. This is going to be really useful. Right now, that's just going to be a little reminder. Okay, I know the video's gone on for 17 minutes, almost 18 minutes already, but I got one other thing I want to talk about in this section. Hopefully this all made perfect sense. It's a nice review. Yay, nice and colorful. Life is good. Dun, dun, dun. Oh, look at that. I know. I snuck that in. Look, we were all happy with the colors, and then bam. Okay, when I was first studying geometry and graphing and stuff, I looked at this and I was like, oh my gosh, what am I going to do? This is horrible. Not horrible. Let's look at what it's actually asking. So I've got 2 ordered pairs. And notice instead of calling this one XY and this one calling this one XY, that would be like telling a joke. And you're like, one day, Dave walked up to Dave and said to Dave, hey, what's your name? And Dave said, Dave is my name. The whole thing is too confusing. So if you're going to tell a good joke, you say, one day, Dave walked up to Barbara and said, hey, you know, etc. So what are we doing here? Well, mathematicians, we're a special bunch, but we use something called Subscript so that you can see that this is X sub 1 and this is X sub 2. This is Y sub 1, this is Y sub 2. The subscripts are going to tell us that these two go together. They belong in the same family. They've adopted the same last name, if you prefer. X2 and Y2 go together in the same way. So it's reminding you that these are both X's and these are both Y's, but it's also telling you that these two go together in a single point and these two go together in a single point. So it's kind of cool. I know, kind of, you know, brain boggling. But people will be very impressed. Show people this, they'll be like, ooh, you must be so smart. And you say, yes, I am so smart. because you are. X1 plus X2. So you take the two X's, these two values, add them together, divide by 2. What is that? You're taking an average. Average the X's, average the Y's. That's all you're doing. I know it's fancy. It looks all complicated, but it's just add the X's, divide by 2. Add the Y's, divide by 2. And what are we finding? We're finding the midpoint. So if I have, oh no, what have I done? I ate I seriously did. I have done away with my ruler. So here we go. This is as straight as I get today. So if you have 2 points and you draw a segment between them, the point that sits right in the middle is called the midpoint. This is useful for things. For example, if you have 2 people and you're like, we should meet in the middle, where would we meet? Boom, just like that. Or I've got the ends of a pipe and I want to cut it in half. I would cut it right there. Well, various things. I'm sure we could come up with some better examples. So if I give you the 2 points, 1, -3 and -2, -4.5, let's see, the way I've drawn it, this one is further to the right. So this would be 1, -3, and this would be -2, -4.5. And now I'm going to do something magic. You ready? You ready for magie? Magie. And I'm sorry, someone is writing a transcript of that, so I shouldn't throw in strange French words. I'm just saying magic in French because it sounds fun. Magie. Anyway, I think it's in French or perhaps another language. So maybe I'm just saying gibberish. It's possible. So the magical thing I'm going to point out here is I'm going to write not to scale. And when I write not to scale, it means that this is not the way it would actually look on a graph. I've just randomly drawn a line segment in. So that's magic. Use that. Hold on to that magic word. Those magic words. Okay, so I want to find the midpoint. So what I'm going to do is I'm going to take the 2 X's. Let me write them next to each other. Like this. I'm going to take the X's. And I'm going to add 1 plus a -2 all over 2. So that's 1 plus -2 is -1 over 2. So it's either -1 over 2 or -0.5. A lot of times mathematicians will stick with the fraction, but if you're not otherwise said that you can't use it, you can usually use decimals as well. The exception to that would be if this is not a nice number. So if we're like -1/3, then you should write it as a fraction because it doesn't have a nice terminating decimal approximation. Okay, and let's look at the Y's. Okay, the Y's are -3, parentheses, plus a -4.5. Oh, this one's going to be a little gruesome. -7.5 over 2, which if I use my calculator or my brain, I think it's going to give me -3.75. You know what? I don't trust myself. Guess what we got? We got a calculator. Isn't that awesome? 7.5 divided by 2. Yes! Okay, so here are the Y's. And so my midpoint is going to be at -0.5, -3.75. Bam. There you go. A bit of a long video, but here we're done. I think this should give you enough so you can get through the homework in 2.1. As always, if you are looking at this and realizing you're a little rustier than you realized, you're realizing there were some gaps in the things that you learned, come talk to me. Come to office hours. Talk to me about, we can set you up with some office hours for tutors if that's easier or more comfortable. You can discuss it with your fellow students. I am a big fan of group work on homework. So, woohoo! Let's get her done. Okay. So, woohoo! We are done. Woohoo! Math on. Yay!